Hello everyone, I'm Hemant Bhatt and I'm a consultant with Encryption Consulting. This video is going to be about the latest release of OpenSSL 3.2.0. I will be walking you through the most important features that have been introduced. OpenSSL is a comprehensive cryptography library that provides an open source implementation of the TLS protocol. It empowers users to execute a range of SSL related functions such as generating certificate signing requests, creating private keys, and installing SSL certificates. Some of the new features that have been introduced include client-side quick support. Quick is a transport layer network protocol designed by Google. The primary objective is to minimize latency in comparison to that of TCP. TCP faces inherent performance limitations such as large handshake delay in establishing connections and head-of-line blocking, and this is why a protocol like Quick is important. Support for multiple streams has been added as well. When a quick connection is created, by default it operates in default stream mode. The default stream mode is intended for compatibility with existing applications. New applications using Quick are recommended to disable default stream mode and use the multi-stream mode. The next feature release after OpenSSL 3.2 is expected to include Quick server support as well. Next we have certificate compression. The integration of certificate compression using zlib broadly and zstandard in OpenSSL 3.2 has the potential to optimize the performance and efficiency of secure communications by reducing the latency. Compressing certificates minimizes the volume of data transmitted during the TLS handshake, resulting in decreased latency and faster connection setup times. This also leads to improved bandwidth usage. It can particularly be beneficial for end users, especially those in regions with slow internet connections or using mobile networks. The reduced data transfer can result in a noticeably quicker and more responsive experience when accessing secure websites. Support for new cryptographic algorithms such as ED25519CTX, ED25519PH, ED448PH has also been added. Some algorithms such as ED25519 and ED448 were already supported. Support for deterministic ECDSA signatures has also been added. Elliptical curve signatures that follow a deterministic approach like deterministic ECDSA and EDDSA are becoming more popular compared to randomized ECDSA. This popularity stems from the fact that their security is not reliant on a source of high quality randomness. Adding of secure ciphers means more security. With so much internet traffic, security of data becomes paramount. So, the default SSL TLS security level has been changed from 1 to 2. This modification will strengthen encryption algorithms and enhance key lengths, raising the difficulty for attackers to exploit encryption vulnerabilities. It is expected to phase out outdated and less secure protocols and ciphers, promoting a modern and secure communication standard. Nevertheless, there is a potential for compatibility issues with older systems that lack support for these heightened security standards. Other features that can generate incompatibilities are the production of X.509 version 3 certificates by the X509 CA and REC apps, and that subject or issuer names in X.509 objects will now be displayed as UTF-8 strings by default. Hybrid public key encryption has also been introduced. The blending of asymmetric and symmetric algorithms in encryption schemes has been outlined and employed since the inception of public key cryptography. This combination harnesses the key management strengths of asymmetric cryptography along with the performance advantages of symmetric cryptography. This can make communications more efficient. The ability to use raw public keys in TLS has also been added. Raw public keys are being used for securing communications between clients and servers. They serve as a means of presenting a public key without the accompanying digital certificate, which typically includes extra details such as owner's identity, expiration date, and digital signatures from a certificate authority. This characteristic renders raw public keys more lightweight and efficient, particularly in environments with limited resources. TCP Fast Open support has also been added. TCP Fast Open is a transport layer solution to eliminate one full round trip time between client and server. This negates the need for the TCP three-way handshake in the case of repeated connections. A single round trip time represents a significant duration for short-lived and time-sensitive traffic, such as web traffic, which includes activities like browsing websites. The degradation in performance becomes more pronounced in scenarios with elevated propagation delays, such as a link between a ground station and a satellite, or when the mobile network operates at a low pace. Support for provider-based pluggable signature schemes in TLS has also been introduced. This enables seamless integration of post-quantum cryptography techniques by third-party providers. It also improves OpenSSL's flexibility, allowing users to select post-quantum cryptographic schemes that align with their specific security needs or adhere to industry standards. This flexibility will help OpenSSL stay ahead of the ever-evolving cybersecurity landscape and keep the communication channels updated. Support for using the Windows System Certificate Store as a source of trusted root certificate has also been introduced in the latest version of OpenSSL. This will definitely impact interoperability. However, this functionality is not currently activated by default and requires enabling through an environment variable. These features add to the versatility and flexibility of OpenSSL and make things much easier for users all around the world. I hope you liked the video. For more of such content, please visit www.encryptionconsulting.com. Thank you.